Title: Crash Course Instrumentation. Saturday Special Episode 6, The History of Breadboards and Circuit Prototyping. Welcome to another Saturday Special from Crash Course Instrumentation. Today, we're taking a step back from the workbench and diving into the fascinating history behind one of the most essential tools in electronics, the breadboard. Along the way, we'll explore the rise of circuit prototyping, the birth of the integrated circuit, and how all of it helped launch what we now call Silicon Valley. Where did breadboards come from? Before solderless breadboards were invented, electronics hobbyists and experimenters used literal wooden cutting boards to hold components. They'd nail brass strips or mount terminal posts onto these boards to create temporary circuits. The term breadboard stuck around even as materials evolved. This hands-on trial-and-error style of building became the foundation of electronic tinkering. Fahnestock clips and point-to-point wiring. Early 20th century prototyping used Fahnestock clips and metal chassis to connect components directly with wires. No PCBs, no solder masks. Point-to-point wiring was common in radios, telephone exchanges, and early test gear. This labor-intensive method required good planning and careful soldering, but allowed for fast modifications. The evolution of prototyping platforms. 1940s. Point-to-point wiring dominates hobbyist and professional builds. 1950s. The emergence of perfboards and turret boards offers reusable prototyping. 1960s. The solderless breadboard is introduced by Ronald J. Portugal. Its internal spring contacts allow for rapid circuit building with no heat or tools. 1970s. Breadboards become standard in educational labs and startup garages across the U.S. Present day. Arduino systems are sweeping the country and being used to teach a new generation of kids about electronics that incorporates computer programming and sensor-based control systems. Integrated circuits in Silicon Valley. In 1958, Jack Kilby at Texas Instruments and Robert Noyce at Fairchild Semiconductor independently developed the integrated circuit, IC. Kilby built the first working prototype using germanium, while Noyce's silicon-based design could be manufactured more easily. Noyce went on to co-found Intel in 1968 with Gordon Moore. This advancement enabled entire circuit functions to be squeezed onto a single chip, perfect for the compact designs hobbyists and entrepreneurs needed. The ability to prototype these IC-based systems quickly on breadboards was critical to innovation in the late 60s and 70s. Steve Wozniak and the Apple. Steve Wozniak famously designed the original Apple I computer using a solderless breadboard in his garage. With no formal backing or resources, Woz prototyped the design using off-the-shelf components and a breadboard, demonstrating how a single individual could produce a market-ready design with modest tools. Wozniak later soldered the final version onto a PCB for production, but that original breadboard phase helped him iterate, debug, and refine the machine that would launch Apple. Why Silicon Valley? Much of this innovation clustered in California's Santa Clara Valley due to A. the presence of Stanford University and its focus on practical electronics, B. military and aerospace investment during World War II and the Cold Wars. The migration of semiconductor talent from Shockley Semiconductor to form Fairchild and later Intel, the Traitorous 8, were a group of engineers who left Shockley Semiconductor in 1957 due to management conflicts with William Shockley. This elite group, including Robert Noyce and Gordon Moore, went on to form Fairchild Semiconductor, and many of them later played key roles in founding iconic companies like Intel and AMD. Their departure marked the cultural beginning of Silicon Valley's startup ecosystem. From the Traitorous 8 to the rise of venture capital, Silicon Valley became the epicenter of hardware innovation, much of it built on fast, flexible prototyping methods. Modern tools still reflect this legacy today. Prototyping continues with 1. Breadboards for initial testing. 2. Perfboards for semi-permanent builds. 3. Wire-wrap sockets in telecommunications and high-reliability systems. 4. Simulation software like LTspice, KiCad, Tinkercad, and Multisim. Yet, The humble breadboard remains an essential tool for students, engineers, and makers alike. It embodies the spirit of experimentation and learning by doing. Whether you're building your first LED flasher or designing a mission-critical PCB, remember, it all started with a literal wooden board and a handful of wires. Watch more videos. youtube.com at Crash Course Instrumentation. Join the conversation. www.facebook.com. Groups 172542290473751. Instructional references, courtesy of Tony Coupalt and the open source Model project, http://ibiblio.org. Coupalt, Socratic, Model SAR Index. HTML.